In this video, we'll be dealing with this particular animation. We're going to go step by step, but in the process, we're going to learn how you should think while creating things in GeometryNode so that you can tackle problems on your own animations and you'll get an idea of how to solve them and the thought processes that you should be going through. So let's actually tackle this particular animation while getting better at GeometryNodes. In our default scene, since this is a GeometryNode tutorial, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and we'll change it from the 3D viewport to the GeometryNode editor. Now we'll press new to add in a new GeometryNode tree, and then we can zoom in, select the group input, and press X to delete it. Now the first thing that we want is a circle that's gonna go somehow like this, within which we'll have all of our lines coming in. So to do that, we're gonna have to first create the circle. So let's press Shift A and search for a curved circle and just plug this into the group output. After that, you can see that the circle is not rotated correctly. We want it to be vertical, so we're gonna have to rotate it. We can do that by searching for a transform geometry node and plugging that in right there and rotating it about the x-axis by 90 degrees. Apart from that, I want these circles to be a little larger, so I'll change the radius to 2 meters. But I'll also go ahead and just reduce this resolution so that there aren't that many lines that will be coming out later on. So we'll change this to like 16. Once we're happy with this, we can actually start instancing lines onto every single one of these vertices. And later on, we'll deal with how we orient them. So to instance lines, we press Shift A and search for an instance on points node and plug that in right here. For the instance, we know that we're going to use a line, so we'll search for a mesh line by pressing Shift A and searching for mesh line and plugging that right into the instance. Now the first thing that we see is that the lines are all oriented in the exact same direction and they're way too long. To fix that, the first thing that we can do is change this to endpoints so that we just have a start location and an end location, and we hence know exactly which axis these lines are being drawn on. So right now they're being drawn on the z-axis. Next up, we can control the number of points within these lines, and since we want them to stretch about to a point, we'll be playing around with this very soon. However, for now, we need to figure out how to rotate these so that they all point inward. So the way we can do this is by playing around with the rotation values in the instance on points node. But if you use these values over here, you'll see you rotate all of the instances by the same amount. But we need each instance to rotate individually. And that's why we have to use the fields that's given over here. Now for this rotation, we need to align them to the normals of this curved circle that we have. So the first thing that we have to do is find the normals for this particular curved circle. To find out the normal value at every single one of these points, we have to sample the normals for every single index. So we press Shift A and search for a sample index node, and we can plug the output from this transform geometry node into the input geometry of the sample index. Now we have to figure out what we want to sample. So we want to sample the normal value. So we search for a normal node and we can plug this into the value. However, the normal is a blue dot because it's a vector. And right now we're searching for a float, but we need it to be a vector so that we get the correct direction. Hence, we can change this from float to vector and then plug the normal into the value. Next up, we want to know which indices we want to find the normals at, and we want it for every single one of the indices. So we search for an index node and we just plug this into the index value. So this way it'll iterate through every single index and we get the normal value for each of them. Now, how do we plug this normal value into the rotation? We have to first convert it. So to do that, we can search for an align Euler to vector node. This way we'll be aligning the Euler rotations to a given vector. So we have to give it what vector it has to get aligned to. And that is what we're going to use this value for. So we can plug this right in here. But it has to align based on one of these axes. Now we know that the lines that we just created were on the z-axis. So that's why we're going to have to make sure that it's on z, and then you can plug this into the rotation. And that way you see how it nicely gets aligned to the actual normals of the curve. Remember, you could always try out the different values until you figure out which one aligns it properly. The next thing is actually making them point inward instead of outward. And to do that, you could align it by a negative value, but a simpler method would just be reversing the direction on the z by typing -1 over here. And now they're all pointed inward. And we'll also have to play around with this length later on, so we'll keep it as is for now. Next, we want these points to actually go all the way to some other object. So let's first add in that object that we want. So we press Shift A and search for maybe an icosphere and just scale it down a little bit, and we'll leave it as is for now. Next, we'll select this geometry node object again, and we'll have to set the position for these tips to go to the location of this particular new object that we just added. How do we do that? The first thing that we know is we can set the position of any vertex by using a set position node. So we can press Shift A and search for a set position node. But right now we have an issue because these are instances, and when we set position for instances that are not real geometry, any change will change every instance as a whole and not individual indices. So to change only the individual indices, we can search for a realize instances node and plug that in right here. Next, we have 10 points on each of these, but we want the starting point to remain right here, and we want this ending point to move, and we want everything in the middle to follow along. The easiest way to do that is by removing the 10 points and making it only 2 points. So we'll come back to the mesh line and we'll reduce the count down to 2. So now there's only 1 point here and 1 point here, and if we take this point and we move it around, the entire line will follow with it. So how do we actually figure out how to offset this point? The first thing is we have to isolate just this point. To do that, we can actually use a curve tip node that already isolates the tips for us using this tip selection. But the problem is it works only for curves, and right now it's a mesh. So we can press Shift A and search for a mesh to curve node and plug that in after the realize instances, and now take the tip selection and plug it into the selection. Now if we actually set position, only the tips will move, which is exactly what we want. So we can keep this as 0. Next, we need this offset to be the location of this particular icosphere. So we can take the icosphere from here and just drag and drop it into our geometry node editor. Remember, if you don't do this, you can always press Shift A and search for an object info node and select the icosphere from here. Anyway, we're gonna take the location of this icosphere and plug it into the offset value of our set position. But we have to remember that we can't keep it at original because we're gonna be moving the icosphere and we want all of these to move with the icosphere. So we press relative. And now if we take the icosphere and we just grab it on the y-axis, we should see these points moving, and you can see it's working perfectly all right. But the lines aren't actually reaching all the way to the icosphere, and to fix that, we can play around with the scale on the instance on points node by just dragging this even lower till they're approximately the size of the icosphere or slightly larger. So something like minus 1.5 will do. Now the next thing is that if we actually grab the icosphere on the y-axis and move it too far, we want these to eventually get detached if we cross a certain threshold. So to do that, we can actually delete the geometry if it gets longer than a certain value. And since we're using a curve, we can just find the length of the curve by pressing Shift A and searching for a curve length node and plugging this geometry right in here. Now we can get the length value as an output, but we have to compare it with something. So we press Shift A and search for a math node, and we can change this from add to greater than and plug this length right into the first value. So now if the length of the curve becomes greater than this threshold value, it'll give true. So we want the true values to get deleted. So we can press Shift A and search for a delete geometry node and plug this value into the selection, and we can take this set position and plug that into the actual geometry, and the output of this is what's going to go into our group output. So right now all of these got deleted because the length was clearly greater than 0.5. So let's start increasing this threshold, and you can see that if you increase the threshold to a fairly large number, it gets deleted. So let's start increasing the threshold till we start seeing the points again, and you can see after a value of something like 25, these values are seen. So let's make the threshold maybe 50 for now. Select the icosphere and just grab it on the y-axis and start moving it, and you see the length is getting larger and larger, and once it crosses that size 50, it just gets deleted, which is exactly what we want. And it works on both the sides as well. So that's perfectly all right, and this is clearly working. Next, we have to actually convert these from curves to meshes, and we also have to add in some noise to it. So to add in some noise, we need more geometry, so we can press Shift A and search for a resample curve node and plug that in over here and just increase the count to maybe something like 50. So now there are 50 points within each of these lines. To move them around, you can search for a set position node and play around with the offset. So we press Shift A and search for a noise texture, and we can plug this into the offset value. Now, when we add in this noise, it gets shifted up by 0.5 on all of the axes. So we press Shift A and search for a vector math node, and this vector math, we can keep it on add, or we can change it to subtract and subtract 0.5. So that way it comes back to the center. Next, we obviously don't want it to be this chaotic. So we can go ahead and just increase the scale to something like 10 and press Shift A and search for a vector math node and change it from add to multiply. And now we can multiply it by a very small number, maybe 0.1, just to get these subtle arc-like motions. Maybe 0.2 will also work. Now that we have this, if we take our icosphere and grab it on the y-axis, you can see how we get that electric motion. And based on this, you can play around with the strength by playing around with this multiply vector. So maybe 0.4, would make it even more chaotic, but I'll keep it at 0.25 for now. Next, if you actually switch off overlays, you can no longer see these because they're just curves and not real geometry. So we'll switch on overlays, press Shift A and search for a curve to mesh node. And for the profile curve, we can search for a curve circle and just plug this into the profile curve. Now the radius is way too large, so we'll reduce the radius to 0.001, and that might be a little too thin, so maybe 0.002 will do. We also don't require this much resolution for these curves because they're really small, so we can reduce the resolution to 3 and it'll just help rendering out our scene faster. Now this seems alright. We can grab it on the y-axis and moves really nicely, but we need something for these rays to actually appear from. So let's go ahead and press Shift A and search for a joint geometry node, plug that in over here, and this original circle that we had, we can actually just instance that over there itself. So we press Shift A and search for a curve to mesh node and take this curve and plug it into the curve of the curve to mesh. And for the profile curve, press Shift A and search for a curve circle. Now, once we plug this in, to actually see the curve appear, we can take this mesh and plug it into the joint geometry. If you have Node Wrangler switched on, Alt right click and just bring these together. Now clearly it's way too large and we chose the curve circle before we actually transformed it. So we have to use the transformed version. So we can plug this in over here. And now we have the curve circle, but it's too large. So we reduce the radius of this to maybe 0.2 or 0.15. And since we don't want to mess around with the resolution of this curve and this makes it really blocky, what we can do is reduce the resolution of this curve to maybe 8 and then search for a subdivision surface node and plug that in right over here and increase the levels to maybe 3 or 4, which will make it nice and smooth. Apart from that, we can also just make sure that it's shaded smooth so that even if there are a little bit of edges, it won't be seen. So we search for a set shade smooth node, plug that in over here, and that's about it. Next, we need to play around with the materials for these arcs as well as these rings. So we press Shift A and search for a set material node, plug that in over here, and we can add the same thing after this entire branch over here. So take this set material node, press Shift D, plug that in over here, and we have to actually select the materials. So we'll go to the material tab over here, press the plus to get in another material slot and press new so that we have 2 materials. The first material we'll call rings, and we'll go ahead and select rings from this set material. And for the next material, we'll call it arcs, and we'll go ahead and select that for this set material down here. And with that, we should be done with the geometry nodes section, but we might come around to play around with this threshold value based on our actual animation. Until then, let's start off the actual texturing. So for the texturing, we'll change our viewport display from solid to rendered so that we can actually see the changes. Then we'll go to our render properties and switch on bloom and screen space reflections. Then we'll change our geometry node editor to the shader editor. And we'll actually start off right now. So first, go to your nodes. If you can't find them, press period on your numpad to centralize the nodes. And we have arcs selected. The arcs don't have to be complicated, so we'll just select the principal BSDF, press X to delete it, press Shift A and search for an emission node. Then we can plug this emission value into the surface and we can increase the strength to something really high, maybe 100, and change the color to something more bluish. And that seems all right. I think I'm going to go with the strength even higher, maybe 1000, and that seems fine. If at any point of time you feel like the bloom is going to be too much, you can always play around with the bloom settings over here and just reduce the intensity to 0.02, and that's all right. Next up, to actually see these arcs better, I'm going to go to the world background and just change the color all the way to black so that we see everything better. I think the bloom is still overpowering, so go back to the bloom settings and clamp it down to something like 5. Next, we can play around with the actual rings. So let's go to the rings material and just increase the metallicness maybe all the way to 1, reduce the roughness to 0.3, and that should be it for the rings. For the sphere, right now we don't need the sphere to be this blocky, so we can press Ctrl 2 to add in a subdivision surface of level 2, go to object and click shade smooth, and along with that, I'm actually going to scale this up a bit so that it's more visible and looks better in our final render. And then we'll add in a new material, and just like the others, I'm going to go ahead and just increase the metallic value to 1, reduce the roughness value to maybe 0.4. Next, to enhance the shading, we can search for a background. So press Shift A and search for a mesh plane, scale it up, and then press RY90 and just grab it behind by pressing GX and bringing it back by quite a bit. Then for this material, we can add in a new material, select the principal BSDF, press X, press Shift A and search for a diffuse BSDF, and then just plug this into the surface and increase the roughness value all the way to 1 and increase the value all the way to white and maybe give it a little bit of a bluish tint. Along with that, our actual light, we can give that a slightly bluish tint as well. And we can press Alt G to clear its location and then just grab it on the Z axis to move it up, and that should be all right. Along with that, for the actual arcs, they shouldn't be creating any shadows. So we'll select it, select arc from these options over here, go all the way down to the blend mode and change the shadow mode to none. Similarly, even the rings don't necessarily need shadows. So we can go down to the settings there, change the shadow mode to none. And even the icosphere does not need a shadow. So shadow mode can be none. And with that, you can actually start off the rest of the scene. The first thing that we'll do is actually duplicate this particular icosphere object. We'll actually change the name from cube to electricity emitter, just so that it's easier for us to identify later on. Then select it and press Alt D Y3 and then press Shift R maybe 2 more times to add in 2 more rings on this side, and then take the same original electricity emitter object, press Alt D Y -3 and then Shift R 2 more times so that we get 2 more. Now if we select our original icosphere, press Alt G to clear its location and grab it on the Y axis, you should be able to see the lightning streaks shift from one to the other, and that's exactly what we want. But right now, at most, we have 2 objects actually sharing lightning with it or electricity with it. So I want to increase that number, and to do that, I'm going to go back to my geometry node editor, select the geometry node object, go back to this greater than threshold and just increase the value till a few more get involved. So I'll increase the value to maybe 70. So now if I take the icosphere, grab it on the Y and move it around, there's 3 of them at any point of time that's actually grabbing onto it, and that seems fine. So next we can actually select our camera and position it. So we can press 3 to go into the side view, and then press Ctrl Alt 0 to snap the camera to our current view. Then we can go to our object data properties. With the camera selected, we can change the Y location to 0 just so that it becomes perfectly centralized. Even the Z location we can change to 0, after which we can go to the actual camera properties and reduce the focal length so that it becomes a much more wide angle camera. And that also kind of zooms it out, so we can bring it back in by changing the location on the X and just bringing it in like that. Now something like that seems all right. And the next thing that I have to do is take my light, press Alt D Y and move it a little bit to this side, and also Alt D Y, move it to the other side as well. And my background plane is clearly too small, so just scale that up. Select my camera, go to the camera settings down here, viewport display, passport out all the way to 1. And that seems all right. Along with that, I think I'm going to take all the lights and move them down a little bit. So just select all 3 of the lights from the outliner, GC, bring them down, and that's fine. Next, we can start off with the actual animation. So we'll go to our output properties, change the frame rate to 30 frames per second, set the end frame to 150 so that it's a 5-second long animation. Output folder can be wherever you want it to be. File format, we're going to choose FFmpeg video, and encoding has a container of MPEG-4 with an output quality of perceptually lossless. Then let's select our icosphere, increase the timeline a little bit, press back to go to frame 0, and with the icosphere selected, hover over here and press I location, then go halfway through, but this way we won't get the animation too well. So what we'll do is we'll just press GY and bring it to the side just before the rays break off. So somewhere like this is fine. And then we'll press I location. Then we'll go halfway through to frame 75. Press GY, bring it to the other edge, and then press I location. Then at frame 150, we can go back to the original. So take this keyframe, press Shift D and bring it to 150. Now, to be honest, you could just render out 75 frames. That's all that's needed. And in whatever video editing software you use, you can always just reverse it to go in the opposite direction by reversing the video and compiling that to make one single loop. So that'll save you half the time, and that might be worth it. But for this explanation purposes, for an entire loop to happen, you can go from 0 to 75 in one direction, and from 75 to 150 you can go in the opposite direction. And we're going to keep the interpolation at the default Bezier, which is over here, so that it actually slows down at the beginning and speeds up as it comes to the center, and then slows down again just before it reaches the actual edge. So that makes it seem like these energy fields are actually attracting the ball, and it undergoes simple harmonic motion as it goes from one side to the other and gets pulled in and tries to escape from this side but gets pulled back. And that just keeps happening forever. So that's actually all there is to this particular animation. If you want to see the actual speed at which it's moving, you can change the playback from play every frame to frame dropping. And that'll give you a realistic idea of how fast the ball is moving in your final animation, so that you don't actually speed things up and have the final animation way too fast and things like that. So this seems fine enough for what I was planning. And with that, the last thing that you have to do is press render animation to get an animation like this. Hopefully you learned something from that video, and now you can think through what has to be done to get whatever creation you require in your geometry nodes. The process is just linear thought, and you have to think about what do we need next and how can you achieve it to get the final result. Break it down into simpler steps. The first thing that we did was create the circle. We didn't bother about anything else. Then we tried to figure out how are we going to create the rays, how are we going to get it to follow a particular object, and things like that. It goes step by step to create anything, no matter how complex it is. So with that, I hope this video was useful to you and you learned something new. I post videos every single day, some of them really simple, some of them a bit longer with even more information packed into it. So I'm sure you will find videos that cater to your exact needs. And until the next video comes out tomorrow, keep creating and stay creative.